We're going to fill out this table. I've already got the graphing calculator there pulled up, our output values. Two is 7.39. Same things here. This is going to be a 0.36, 8. Always 1. Anything to a 0 power is 1. We'll answer our questions here in just a moment. So first off, it says which row gives the approximate value of E? Well, anything to a 1 power is going to remain the same. So when we look at this table, the E value to the 1 power is the 2.7183, and it's actually an irrational number. You can see there's several of those. And the reason, the explanation, is because that's what E to the 1 power is equal to. As I just said, the E is a representative of a irrational number. That is a non-terminating, non-repeating decimal, kind of like pi. All right, we're not going to worry about graphing these. We do need to know that the graph, the larger the base, the steeper it is. So 3 will have the steepest bend, 2 will have the least steep, and since the 2.73 or 2.718 base, that's the natural base, since the natural base falls between those, you'll notice that all of its values are between the 2 and the 3 value, and they do all share the 0, 1. We decide which one. We're going to go straight to our transformations here. Remember the natural base of E. Natural base of E, its natural shape is almost like the base 3. It's going to go through 0, 1, and then 1 will be 2.71, just below the 3. So its parent function looks a little like that. But when we drop the 1/2 in front, what we've created, since it's outside of the parentheses, it's a vertical movement. And since it's multiplication, it's either a stretch or compression. And since the number is between 0 and 1, that makes it a compression. So this is a vertical compression by a factor of 1/2. Notice I didn't say negative 1/2 because this is going to be a reflection on top of that. So all of the values we saw from the first one are now going to be half of that. So where it was at 1, this will be at 1/2. Where this was at 2.7, it's going to be half of that. Half, half, half. So if a function, when we take a half, would look like this. It's going to be doing half of those numbers. And when we reflect it, and that's what the negative sign does for us, the negative is a vertical reflection, all of those values will be the half values, but they will be in the negative portion of the graph. So this is a vertical reflection. When we have a vertical reflection, this is going to affect our domain, our range. Nothing affects our domain. A domain on an exponential function is all real numbers. And the range, which is generally all values of all values of y where y is greater than 0, that's what it generally is. But since this has been reflected, we will be seeing the sign flip, because now the numbers that show up on the graph are now below. Whoops, I did it again. No, I did it. The values are below 0. So this would be our domain and range. Yellow would be our ending graph. And you can see I have a table over here and I have a graph, which gives me a pretty good idea of what I'm seeing. The tables are hard to work from with these just because the numbers are irrational. And with irrational numbers, you're not going to get very many integers, like we see 4, 2 here. All right, but let's just talk about the parent function, like we said, where it goes. Remember, anytime we have movement that's taking place inside of the parentheses, now that is an understood parentheses, of course, but anytime we have that movement inside of a parentheses, it's going to be horizontal. So we have a horizontal movement. And since it's horizontal and it's adding or subtracting, remember adding, subtracting is shifts. So this is a horizontal shift. And horizontals always have an inverse behavior. So that feels like that should go left 4, but in actual, when we look at it, it's going to go right 4 units. So the first thing we'll have is a horizontal shift, right 4 units. So where it used to look like this, now it's going to be shifted over 1, 2, 3, 4. So our value is going to be shifted over 4, which does not affect the domain or the range. Nothing affects the domain, by the way. So when we shift it 4, that's what it would look like. But we have another transformation as well, and that other transformation is the +1. Remember, anytime we add to the back of a function, all we've created is a vertical shift. And these are not tricky. This one feels like it should be up because it's +1, and it is up 1. So this one where it was here will now be there. This will be there. This will be there. And we will now be asymptoting at 1 instead of 0. And that is the only way that we do change the range. The domain is all real numbers. Nothing's going to change that. But our range, which is normally 0, has been shifted up 1, and it has not been reflected, so y, where y values are greater than 1. And it will always be equal to that value there. A stretch or a compression. The way it is, breeze right through these real quick. Again, 2 movements here. Shifted down 5 because of the -5. That is a vertical shift because it's subtraction, and it is down 5. We have another action happening outside of the parentheses, which is vertical. It is not adding or subtracting, it is multiplying or dividing, so it is a stretch. And it's stretching by whatever the number it is, by a factor of 2. This gives no change in the domain, so domain is all the same. I'm not even going to mention domain anymore. But the range, which is normally 0, has now been shifted down 5, so where y is greater than 5. Next one has no vertical shift because there's no plus sign. The adding or subtracting we see is actually taking place in the understood parentheses of the exponent. Anything happening inside of there is horizontal. And it is a horizontal shift because it's adding or subtracting. That feels like it should be right, but in actual behavior is left, and it's going left 1. Now if you'll notice, the first two, A and B, both have the 2e, so of course they're going to be the same behavior. So this is also going to be a vertical stretch by a factor of 2. Domain, all real numbers. The range, it did not get shifted up or down. So if it doesn't get shifted up or down, the range is going to stay exactly the same, which is 0. And you can always go over and look at your graph. I have some graphs over there to the right. And those graphs, you can clearly see that, hey, it's definitely asymptoting at 0. We cannot get values below that. And then the final one has 3 transformations. 3 parts are added to the thing. So what we'll do is we will, since it's multiplication in front, it's outside of the parentheses. This is a vertical movement. And when we have a vertical movement, and its multiplication, is where the number is. If the number is between 0 and 1, which this one is, it is a compression. So we have a vertical compression. The vertical compression is by a factor of 1/2. Next thing we'll look at is what's attached inside of the print. Actually, let's stick with the vertical. We have a second vertical thing happening here, and it is adding or subtracting. So it is a vertical shift. Remember, verticals don't have any tricks, so just do what comes naturally, which is down 2. Now that is an effect on our domain, our range, excuse me. And then the last thing we see is inside of the exponent's parentheses, which makes it horizontal. And it is a shift because of the adding or subtracting, and it's going to go right 4 units. So that would be our 3 transformations added to C. All right, this one, the formula. We've used the formula before, but let's just talk about what the parts are. You can clearly see the function there. So the A value is a vertical shift, correction, stretch, or compression, depending on what the number is. Between 0 and 1 is a compression. Everything else is a stretch. The C value, the B is the base. That's going to be E in this case, but the C is the horizontal shift. D would be a vertical shift. And I'm going to add another one that's not showing up on here. We'll put a little pink emblem here. When you have a negative sign in front, the negative in front will always equal a vertical reflection. And then I'm going to do these last 4 with you, the matching. You can graph these if you want, but we can break some things down and determine what these are. For instance, these 2 are finishing towards the bottom, which indicate that they are a negative sign. So it's got to be either 8 or 10. It's got to be 8 or 10. I can also look, since I'm talking about those, this one is crossing through 1, like it's supposed to do, and this one is not. So this one has not been stretched or compressed. This one has been compressed. So all I got to do is look at my base numbers, those A values, and see, okay, this one has been compressed, so B is actually right there across from itself. This one has not been compressed, so 10 is going to be C. Then we look at the other things, and I can see, hey, this function has not been shifted up or down. This one has. So this one, and it's been shifted up 2 because the asymptote is no longer at 0. The asymptote is happening at 2, which means that 2 has been added to the end of this function. So we look and see this one has no plus 2, this one does, so this value has to be A. Now let's justify why 7 is D though. So it's supposed to go through 0, 1. We know that. But it's not going through 0, 1. It's going through 0, 3, which is 3 times more than it should be. It's still asymptoting at 0. It wasn't. See, this one, it's like, well, it's going through 3. Yes, it's going through 3, but you can see it's not asymptoting on 0. It wasn't stretched. It was moved. The whole thing was moved. This one went from 1 to 3, and it kept its asymptote. That's why the 3 in front there has stretched it. And then these last 6 questions or so, these are on you. Let's get those in and submitted to me.